If you're looking for a content explaining what is new with Fluent Bit version 3, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be part of the Open Telemetry and Kubernetes series, where we covered lots of episodes. If you pay attention, I recently released an episode comparing the Open Telemetry collector against Fluent Bit 2.x. During KubeCon Europe Paris 2024, the Fluent community released a fresh new release of Fluent Bit, the version 3. So the question is, what is new in Fluent Bit version 3? Well, in this episode, we will try to answer to these questions by paying attention to the new processors available for metrics and also traces. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what we're going to learn out of this episode. We'll start by looking at all the new announcements on Fluent Bit v3. Then we will look deeply on each new processors, starting with the processors for metrics. We'll see that there are 2 of them. Then we'll look at the content modifier, and last we will look at the SQL processor. One of the most exciting announcements for my end is the HTTP2 support. You may ask yourself, okay, but what does it really mean? Well, it means that Fluent Bit can now receive OpenTelemetry using the HTTP protobuf protocol. You may ask yourself, okay, nice, but yeah, again, what's the value? It means that we can send OpenTelemetry traces with the JZip compression. So this feature is not making any revolution on the way we design our pipeline. It's mainly simplify and improve the way we are going to send the data to our Fluent Bit agent. Please note that as of now, this HTTP support is only true for the input plugin. We should soon expect this enhancement to be available also on the Fluent Bit output plugins. Out of OpenTelemetry input plugin, it also means that we can use the Prometheus remote write plugin to receive metrics using HTTP2. If you're hoping to have Fluent Bit supporting OTLP gRPC protocol, then HTTP2 won't resolve this. So when it comes to OpenTelemetry, Fluent Bit will still be limited to the OpenTelemetry HTTP protocol. HTTP2 is mainly designed to provide a new HTTP engine into Fluent Bit, supporting HTTP2 of course, and previously we had the engine supporting HTTP 1.1. So if you have any solution pushing data with HTTP2, then Fluent Bit will be able to receive this data. The main concern is related to compression. There are many ways of compressing the content with HTTP2. For now, the support of HTTP2 is limited to the JZip compression. So make sure your solution is using JZip to avoid any strange behaviors. In the context of OpenTelemetry, JZip is the default compression. So for us, it is a good news because we don't have to disable the compression in OpenTelemetry before sending our data to Fluent Bit. But out of the HTTP2 support, the major feature that is going to help us are related to new processors. There is a SQL processor. Fluent Bit has introduced this notion of SQL. So it is a new way in Fluent Bit to parse and filter our telemetry data. It is technically an easy language that we could use to define what are the fields that we want to send to our backends. The other awesome news is a fresh new processor that we could use for metrics. It's the metric selector. With the metric selector, we would be able to exclude or even include metrics. Then we have the content modifier that will be helpful for logs and traces. This processor would be helpful for us to adjust our metadata by updating or inserting or even delete keys from our attributes. So let's have a look at those updates with providing few use cases. Like explained in several episodes in this channel, when collecting metrics, we usually want to be able to proceed to specific processing tasks. We want to remove all the metrics that we don't need. Yes, I know that we all have this habit of sending 100% of the metric produced by a given component to our Observability backend, and then figure out what we really need when we design our dashboards. Well, this approach is far from being cost effective. Always look at the metrics produced and try to understand each metrics and understand how important a metric is. It will be the best way of limiting the metrics that we will store in the Observability backend. The second thing that we're looking for is the ability to enrich the metric produced to be able to index our metrics to a specific component available in our backend. So it could be a service, it could be a pod, it could be a server, it could be a namespace. Yeah, I mean, it really depends on which environment you're working on. It often happens that our exporters are producing metrics and is adding also a reference to the infrastructure, so the hosts that is basically hosting this Prometheus exporter. And again, it happens quite often that the label for the server or the pod or the namespace is not standardized. So it's completely a fresh random name. So we probably want to use the standard naming to be able to index. So adding the metadata to the host will be useful when we would need to drill down on a given problem or even crawl it. And moreover, if you have several instances of this component, we want to obviously distinguish behavioral metrics depending on the host or the pod or the cluster or whatever you're looking for. Last thing that we're looking for when it comes to metrics is the ability to reduce the cardinality by removing labels that has a high distributions of values. We often think that metrics is the cheapest signal to store, but in fact, it really depends on the structure of our metrics. If our metric has lots of label, the cost of the storage will be exponential to the number of labels. So if you see that your metric has 50 labels, well, you could consider removing unuseful labels to reduce the cost of the metrics in our backend. The other big aspects on the cost is the cardinality. This is really related to the distribution of the value of a given label. Let's say that we have an exporter that produces metrics with 2 labels, so nothing special. We have the Linux command in one hand and we have the process ID. In the Linux world, we may have maybe about less than 100 potential values for the command label. On the other hand, the process ID has a huge distribution of the values. So one Linux command could have potentially hundreds of process ID. So the storage of this type of metric will simply explode due to the label process ID. Again, are we really going to utilize the process ID to do some statistics, analysis, or even dashboards or SLO? And assume no. So in that case, let's drop the label process ID that would not be useful, and moreover, that will just increase the cost of this given metric. With Fluent Bit 3, it has officially introduced one metric processor called metric selector. If you remember well, I mentioned during the episode comparing Fluent Bit to the collector that Fluent Bit is not supporting scrap config in the Prometheus input. Well, now with this new processor, it's not a big deal anymore. Metric selector will allow us to exclude metrics or only include specific metrics. For example, let's say that we have a Prometheus exporter and we want to drop all the metrics having scrape in the names, go or up, or even remove a specific metric name called Kepler process encore Joule. So we can simply exclude those metrics by configuring our processor the following way. So here it is. From this example, we can clearly understand that the metric name can take either the full name of our metrics or irregular expressions. And actions can be either exclude or include. This is a great news, but you may say, great, but how can we drop labels and to reduce the cardinality? Well, the other great news that was not officially announced is that Fluent Bit version 3 comes with a processor named labels. This processor doesn't have all the feature yet, but at least the feature that we're looking for, which is deleting unuseful labels, is fully operational. So in our previous example, if we want to drop the label container ID or process ID, which is going to be PID, we can simply do it the following way. Labels seems to have more operations to insert, update, hash a given label. So it means that we may be able to insert extra labels in our Fluent Bit pipelines or utilize update to change or rename a given label. In fact, I have tried to use update to rename a label, but so far the expected results was not there. So for example, I tried to rename pod_name into Kubernetes pod.name, and same thing for the namespace, so container namespace into Kubernetes namespace name. Well, it didn't work, but it probably means that in the next coming minor releases of Fluent Bit version 3, we should be able to do such operation. Otherwise, as mentioned in the episode comparing Fluent Bit and the collector, there is still no processors helping us to convert cumulative metrics into delta. So let's cross the fingers. Maybe it will be added soon into Fluent Bit version 3. Content modifier is a processor that is only compatible with logs and traces. As you can see in the name of this processor, content modifier is there to modify our traces or our logs by inserting new keys, updating or upsert, delete, rename, extract content with the help of regular expressions, and even convert. If you paid attention to the episode introducing Fluent Bit or presenting Fluent Bit v2, Fluent Bit had already a filter plugin allowing to do the similar operation called modify. So why creating a new processor where there is already a similar plugin that do the similar actions? Well, first, this processor is not limited to logs anymore, but it's also compatible with traces. The other advantage of using processor instead of filter plugin is related to performance. When chaining processor just one after the other one, just after receiving some data, there is no encoding, decoding between the streams. So we are removing internal operations within Fluent Bit. So at the end, Fluent Bit is more efficient. So let's have a look at the configuration of the content modifier. The content modifier has several properties. So we have the actions that we have listed before. So insert, upsert, delete, rename, extract, and so on. Key to specify the key that we would like to modify in our actions. We have context. It will help Fluent Bit to understand where it has to apply the changes. For logs, we have the attributes in one hand and the body. So either the properties of a logs or either the entire log line. For traces, we have more options. So span name, span kind, span status, and span attribute. This notion of context is not new for us. If you paid attention, the open telemetry community utilized this notion of context that is, of course, slightly different in the transform processors to specify which information would be impacted by our transformations. So if you go back to the content modifier, depending on the value of the actions, we would need to configure extra properties like value in the case of insert or upserting or rename. Extract will require to define patterns where we will build the regular expressions to extract the various data. Convert will require to specify the converted type that will be either a string, a boolean, or integer. For example, to do a simple delete, so here is an example. Here we simply use the action delete, precising that we want to delete the key 2. To obfuscate the sensitive data, we could use hash. Here is an example. So here, similar, we have a log stream with username and password, and we'll say we want to hash the password. So we'll use the content modifier with the action hash, and we precise, of course, the key that is going to be the password. And when dealing with logs, of course, we will probably extract information. So we're probably going to use extract. So here is an example of extract where we have a log line with an HTTP URL, and maybe we want to extract different information from that URL. So we can use the content modifier with the extract, and you can see here in the pattern, we precise the HTTP protocol, the domain, the path, the query, and so on. And each of those elements will become new attributes in our stream. When the SQL processor was announced on Fluent Bit version 3, I thought, that is not new. I remember that Fluent Bit version 2 already had this notion of stream processing that had to be enabled, first of all, in the configuration of Fluent Bit, and that could apply queries to extract content or run even aggregation queries. Stream processing compared to the SQL processor is completely different. Stream processing is only happening after the filter plugin, while SQL processor is being applied on the same thread as our input plugins or even our output plugins. The SQL processor is a fresh new actions for only logging for now that will probably completely change the way we design our logging pipeline. To be 100% clear, when using this processor, you don't need to add any extra storage. Fluent Bit will run the query on the fly against our data, named in Fluent Bit stream. The other important thing related to the SQL processor, especially if you're used to use SQL language, this processor is mainly considered to filter our data. It means that if you're planning to do any statistics or analytics like counting, grouping, or more, then this processor won't be able to do that, at least for now. Think more of the SQL processor like a filter plugin. Let's say I want to only push a limited properties of my logs to the backend, then the SQL processor will allow us to do that very easily. For example, if I only want to push namespace, the pod, the cluster name, and of course the content of the log, then I could have the following processor. So here you can see that I'm applying it into directly to the output, to the std out, and here I'm saying select, and I'm precising the field that I want to send to std out. The other great use case that I see is using the SQL processor to limit the logs to specific backend. Let's say that I want to send logs to Loki, but only the one produced from the namespace hipster shop. Or and I want to send to Elastic the logs produced from the namespace hotel demo, and then everything to Dynatrace. So then the SQL processor will help me to route the logs properly without any major effort. So here is an example. I have defined 3 output plugins, so open telemetry for Dynatrace. There is no processor defined. I have the one for Elastic, where here I'm putting conditions where the namespace is equal to hotel demo. And last we have Loki, where same thing, I make the where conditions on the namespace hipster shop. The usage of the SQL processor could be also, it's quite similar to the modify plugin, but it's great because at the end we have a lighter pipeline, because remember with the filter modify, you can remove fields, but you will have to do one line per fields. So at the end you have a very big pipelines. And while using the SQL processor with one query, you just put the field that you need and that's it. So big thumbs up for the Fluent community for this plugin, because I think it will be very, very helpful in the way we design our pipeline. The only thing I really, really hope that the SQL processor will also support traces. That's it for today's episode related to Fluent Bit version 3. As you can see, I'm very excited to have a couple of amazing processors that will basically improve the way Fluent Bit deals with metrics and also with traces. I think the content modifier is great news. We can easily add new attributes into our logs and traces. And so I'm very happy to see that. The second thing that I'm really excited about is the SQL processor that will clearly be a game changer on the way we design our pipeline. The only thing I would hope is to have this SQL processor supporting traces. It will also be great to do some operations on the tracing aspect. And then last, one thing that I was completely astonished about is the metric selector. So they announced only this processor that allows you to include or exclude or include metrics. But when I discovered this label processor, and I immediately understood that you can do amazing things. So dropping labels, and potentially at the moment it's mainly dropping labels, but I hope that soon we will be able to rename fields, to do more operations on our labels to reduce the cardinality. And again, this is a call for actions to the Fluent community. Please put the cumulative to delta processor, because at the end, if you use any backend supporting delta, you still need a collector to do the transformations. All right, so if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.